Hello guys, in this video I'm going to be sharing the solution for the problem C, Nikita and LCM that was in the Codeforces round 948 diff 2. So in this problem they have given us an array of integers. So they have given us an array of integers. Suppose the array of integers are a0, a1, a2, a3, a4 and so on till an minus 1, where n is the size of the array. So what we have to find is that we have to find a subsequence uh, from this array of integers such that the LCM of that subsequence is not present in the array that they have given us. So we have to find some random subsequence. Suppose the subsequence that we chose is a of I, a of j, a of k, a of l, something like this. And if we take the LCM of all these values, it should not be present in the original array. The LCM of all these values should not be present in the original array. We have to find the longest subsequence which satisfy this condition. We don't have to print the longest subsequence, we just have to output the length of the longest subsequence. Okay, that's basically the problem. The problem, yeah. And the solution for this is, okay, the solution for this is basically what we have to do is that initially we have to we have to check whether we can take the entire array. When can we take the entire array? We can take the entire array if the LCM of the entire array is not present in that array itself. So we find the LCM of all these values and we check whether that LCM, suppose that LCM is like suppose that LCM is L1. We check whether the value L1 is the LCM of LCM of a0, a1, a2, till an minus 1. We see whether this L1 is present in the original array. If it's not present in the original array, we can take the entire array as an answer, right? Because this satisfies our condition. So the length of the longest common subsequence, longest subsequence is n. That is the length of the original array. But if it doesn't satisfy if this L1 is present in the array, if this L1 is present in the array, we have to find some other longest subsequence. Okay, now I will give you one observation. The main observation is that this L1 will be either greater than the maximum of all the elements present in the array that they have given us, a1, a2, a3 till an minus 1, or equal to the maximum of all the elements that they have given us in the original array. So the L1 is the LCM of all the values in the original array. It will either be greater than the maximum of all the values in the original array, or it will be equal to the maximum of all the values in the original array. Okay, so when it's greater than the maximum of all the values in the original array, then the condition of taking the entire array as a subsequence is satisfied. But if L1 is equal to the maximum of all the elements in the array, we can't take the entire array as a subsequence. Yeah. Okay, now you may ask, why can't L1 be less than the maximum of all the elements present in the array? Why can't this not work? Because this is the basic property of LCM, right? LCM means it's the lowest common multiple of all these elements, lowest common multiple. The lowest common multiple will either be greater or equal to the all the elements present in the array, right? So it's the basic property. So it will never be less than the maximum of all the elements present in the array. Okay. Okay. Now, uh, so we have satisfied went to the first condition. If L1 greater than the max of elements in the array, we directly print n, which is the length of the original array. We print n. Now we have to solve for the second condition. The second condition is that L1 is equal to the maximum of the elements. Okay, L1 is equal to the maximum of elements. So okay, so suppose the maximum of the maximum element is, suppose aj. The maximum element is aj. Since L1 is equal to aj, we know that all the other elements will be a factor of aj. What do I mean by that? Okay, the video got suddenly turned off. Since L1 is equal to aj, we know that all the other elements in the array will be a factor of aj. What do I mean by that? What I mean by that is that, suppose you are given an array 2, 3, 6, 12. If you take the LCM of this entire array, the LCM will be equal to 12, and it's equal to the maximum element in the L1 is equal to 12, and it's equal to the maximum element in the array. So the maximum element in the array is 12. All the elements present in the array will be a factor of the maximum element in the array if the LCM is equal to the maximum element in the array. Okay, check 2. 2 is a factor of 12. Check 3. 3 is a factor of 12. Check 6. 6 is a factor of 12. Check 12. We don't need to check 12 because 12 is the element that we are considering, but just check 12. 12 is a factor of 12. So if LCM is equal to the maximum element, all the other factors present in the array will be a factor of the maximum element. Or since LCM is the maximum element, it will all be factors of the LCM itself. So that's one major observation that we have to make. Okay, so if there was some element which was not a factor of 12, if there was some element inside here that was not a factor of 12, suppose what element is not a factor of 12? Suppose 5 is not a factor of 12, right? 5 is not a factor of 12. Suppose there was a element such as 5 inside the array of elements that was not a factor of 12, the LCM would not have been 12. The LCM would be now, okay, what's the LCM of 5 and 2? 5 and 2 is 10. What's the LCM of 10 and 3? 10 and 3 is 30. What's the LCM of 30 and 6? 30 and 6 is 30 itself. What's the LCM of 30 and 12? 30 and 12. What's the LCM between them? 24. Okay. It's 60, right? 60. Yeah. The LCM of 30 and 12 is 60. So it's completely different. It's not equal to the maximum element. So if the LCM is equal to the maximum element, all the other elements will be a factor of 12. That's a condition. Like if you think about it, you will be able to understand that it will be. It's a mathematical condition. Okay. Now what we can do is that and another property is that all the elements will be a factor of 12, as well as all the all the LCM of every subsequence of this array will be a factor of 12 as well. So, suppose if we take 2 and 6, that's a subsequence, say 2 and 6. So, what is the LCM of that subsequence? That's 6. That's a factor of 12. That's a factor of 12. If you take 3 and 6, what's the LCM of the 3 and 6? It's 6. That's a factor of 12. So not only is every element a factor of 12, but every subsequence of this array a factor of 12 as well. So that's another observation that we have to make. Okay, now what we have to do is that since every subsequence and every element is a factor of 12, we have to check whether there exists a factor of 12. There exists a factor of 12 such that factor of 12 is not present in the array, as well as it is a subsequence of some subsequence of some it's a LCM of some subsequence. So what do I mean by that? Okay, in this example, the condition will not satisfy. In this example, the condition will fail. So what do I mean by this? What are the factors of 12? The factors of 12 are 2, 1, 2, 3, 6, 12, right? Since since every factor is present in the array, okay, 1 is not present in the array, right? Okay, 1 is not present in the array. So since 1 is not present in the array, we can try to form 1, but to form 1, no elements will make us form 1. So that will not be possible. So I will give you another example from the test case that they have provided us, so it will be much more clearer to you. Okay, I will give you this example, this test case. 3, 2, 10, 20, 60 and 1. So this is the test case that they have given us. Okay, what is the LCM for this entire array? The LCM for this entire array is like, if you do a quick calculation, it will be equal to LCM is equal to 60. And what is the maximum element? Maximum element is equal to 60. So we have to check the second condition, these conditions. So we have to find every factor of 60. We have to find every factor of 60. The factors of 60 are 1, 2, 3, 6, 10, 20, 30 and 60, right? Yeah, these are the factors of 60, and we have to check one by one whether these factors are present in the array. If they are present in the array, there is no use of them. If they are present in the array, there is no use considering them, because we have to find an LCM that is not present in the array, right? So if they are present in the array, we can directly avoid them. If they are not present in the array, we have to check whether any subsequence can form that particular factor. Okay, now first we check 1. Okay, 1 is present in the array, so there is no use considering that. We check 2. Okay, 2 is present in the array, there is no use considering that. Then we check 3. Okay, 3 is present in the array, there is no use considering that. We check 6. 6 is not present in the array, so we can consider that factor. So and now we can consider that factor. Now we have to see whether we can form 6 with some of the elements present in the array. Actually we can form 6 with 3 and 2. So this is a valid answer. So currently the longest subsequence length is equal to 2, because we have used 3 and 2. So the longest subsequence length currently is 2. Then we see whether 10 is present in the array, 10 is present in the array, so we no need of considering that. Check whether 20 is present in the array, 20 is present in the array, so no need of considering that. Then we check whether 30 is present in the array, 30 is not present in the array. Since 30 is not present in the array, we will check whether we can form 30 with some of the elements. Okay, 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 okay. Actually, in the previous example, 6, not just 3 and 2, we can also consider 1 as well for creating that subsequence with, right, 1, 3 and 2, and I just need 1, that's why. Okay, we will try to include as many elements as possible, because like we need to find the longest subsequence, right? So we will include 1 as well. Now we will check whether what elements can be used to form 30. We can use 3 to make 30, we can use 2 to make 30, we can use 10 to make 30, we can use 1 to make 30. Okay, we got 4 elements. Now we will check 3, the LCM of 3, 2, 10 and 1 is equal to 30. LCM of 6 and 2 is 3 and 2 is 6. 6 and 10 is what? 6 and 10 is 30, right? 30. 30 and 1 is 30. So now we got a much longer subsequence. So the length of the no longer subsequence is 4. Now we will check whether 60 is present in the since 6 is present in the array, there is no need of considering that. So this is the the logic for the given problem, and this is how we so I just wanted to tell you the logic for the given problem, and I will share the code for this problem as well. I will share my code. I will show you my code as well. Okay, so this is a quick run through of my code. Uh, Actually, it's a simple. Okay, not simple. This is a simple code actually. So this is the I defined a function to compute the LCM. I think there is an inbuilt LCM function. You just have to use LCM, and you have to just give the two way variables that you want to find the LCM of. Okay, so initially I am inputting the array elements, and I'm also using a map to keep track of how many elements, how many count each element, how many times each element is present in the array. You can use anything another map as well, and I'm using int max is equal to 0 to keep track of the length of the longest common subsequence. Am I using longest common subsequence? Longest common longest subsequence, yeah. And here what I'm doing is that, okay, okay, there is actually one condition that we need to take care of. It's associated with the overflow. So what I'm doing is that I'm initially uh, checking the LCM of the entire array. I'm checking the LCM of the entire array, and I'm checking whether if the LCM of the entire array is not present in the array. If the LCM of the entire array is not present in the array, we can directly print the size, the n, right? So that's what I'm doing here. I'm directly printing n over here, the length of the entire array. If the LCM is not present, if the LCM of the entire array is not present in the array, I'm directly printing n. And one condition that we have to take care of is that is the LCM can be very huge and can sometimes overflow. It can exceed uh, long bounds. So I am creating a condition to check for that. Okay. Now, okay. Now in this code, what I'm doing is that I'm checking for the second condition when LCM is equal to the maximum element of the array. So I'm iterating through all the devices, factors or devices of the LCM of the entire array, and I'm checking whether that LCM is not present in the array. If the LCM is not present in the array, I'm iterating through I'm iterating through the elements of the array and trying to trying to see whether we can form that that factor using some subsequence of the array. I'm trying to see whether we can form that factor using some subsequence of the array. And if we can do that, what is the longest subsequence that will do so? And I will update the max count if count is greater than max. Okay, that's basically the entire code. So you can go over to my submission. This is the submission link, and you can see the code.